Hey, fourth grade. I'm going to work today on seeing different multiplication problems in models. Instead of, as I usually do, where I show you a multiplication problem and you make a model, I'm going to show you some models today. You're going to make the multiplication problem, and I'm going to show you a little twist on it that often gets asked that I want you to see as well. So make this the title of your next free page. When you have done that, mark your page with your math notebook, close it up, and listen to me until we get to we do. I want to go back over a quick word first, unit fractions. It's been a little while since we've used the word unit fractions. Unit fractions, two ways we kind of looked at those. One way was we looked at them as just sort of any fraction with the numerator of 1. So like that's a unit fraction, and that's a unit fraction, and that's a unit fraction, and that's a unit fraction. And then, fractions with numerators more than 1 or not. Like that, and like that. Those are not unit fractions. So the other place, the reason they kind of had those names when we looked at fraction bars, we kind of saw why they were unit fractions in the fraction bars, like kind of like where the name came from. Go. So we looked at fraction bars like these a lot. I need these advertisements, that's new. Close. And so unit fractions, we called that because, when we pulled them out, they were like one of the pieces. So if we made like 3/4, we made it out of 3 1/4 pieces, 3 different unit fractions together to make 3/4. So unit fractions are the ones that over here would be one piece, one unit. It's like 1/4, 1/5, 1/6. So we called those unit fractions. And that word's going to come up again today. And I just wanted to remind you. So here's what we're going to do today. So I'm going to show you a question like this. So here's a multiplication model that you might have drawn if I gave you a problem to do to solve it. And I'm going to ask you to look at this, and we're going to write the question that somebody would have answered to make this model, or like the multiplication problem they would have seen. But I also want to show you a little twist on it. And we're going to make a second one called a unit fraction multiplication over here. So when I look at this, I need two things. When I'm looking for a multiplication problem, something times something equals something. Right? I'm trying to make that from this model. So when I look up at this model, here's what I see. Here I would have made it this way from this kind of problem. I notice each time the color changes, light blue, dark blue, orange, pink, red, each of those color changes is 3/4. There's 3/4 drawn in light blue. There's 3/4 drawn in dark blue. There's 3/4 drawn in orange. There's 3/4 drawn in pink. And there's 3/4 drawn in red. Right? All those fractions are the same amount. They're the same kind of quantity. And they just change the color. So I see 3/4 1, 2, 3, 4, 5 times. So typically the problem I would say I see there is 3/4 times 5. Or I don't care if you reverse them. If you want to say I see 5 times 3/4, same thing. So that's the beginning. And then I also, of course, need to fill in my what they equal. 5 times 3/4 equals 1 hole, 2 holes, 3 holes, and then there are 3/4 there. So I've got 3 holes and 3/4. So that's what we would typically do with that. We would say I look at that and I see the problem 5 times 3/4 equals 3 3/4. So I want to show you another way to look at it that sometimes little twist that'll be thrown into these questions is sometimes like in a multiple choice question they might say, okay, this is what you obviously see, and they would put some other choices that look a little different. So another way I want you to look at this is when you look at a problem that involves multiplication, you can also look at it as a unit fraction multiplication problem too. It's probably not the first thing you would see, but when you look at it carefully, it's there. So another way I could look at this, it's almost like I ignore the colors here and say, what if those were all the same color? What multiplication problem would I see? And I'm going to use unit fractions to do it. So when I see this, if I ignore the colors, I really just see 1/4 a lot of times, right? 4 in this one, 4 in this one, and so on. I'm not going to write them all in because it takes a long. I guess I could. It won't take me that long. So I see like all these different 1/4 pieces, and if I ignore the color, they're all the same fraction. They're all just 1/4. So if I look for a unit, like sort of like a unit fraction way of showing this, I can just say I see 1/4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times. And of course it still equals the same amount. It still equals 3 3/4. Or sometimes when I write it with all unit fractions, I almost like I want to say there are 15 1/4. So sometimes I like to write the improper fraction as the answer in these cases too. 1/4 times 15 equals 15/4. Either one's okay. So I want you to be able to look at a model like this and say, okay, I kind of can see how this would show me 3/4 times 5 with the colors. Or without the colors, I can just see it also shows me the same question of 1/4 times 15. And it shows me that those are the same. Right? That's really what it's cool to look at the model. It really kind of shows me that 5 times 3/4 is the same thing as 15 times 1/4. Like those are like two of the, they're both going to give me the same thing, 3 3/4 or 15/4. It's two different ways to look at the same situation. Okay? Let's do one together. Open your notebook. And let's look at this one. So I did this all with one color, because sometimes you see them that way. We talked about how like if you don't have different colors to use, sometimes you just have to use different shading patterns. So go ahead and take a moment and draw that as you read it. Usually when you look back at this in the future, you know what problem you were talking about. And we'll talk about the kind of the usual multiplication problem you would write down here, and then the unit fraction multiplication you would write down here. So when I look at this normally, if I'm going to say what multiplication problem does this show me? So I see these divided into thirds, all the circles, all the fraction circles are in thirds. And each color pattern has 2 of them. So there's 2 in this dark pattern, there's 2 in this up and down stripes, there's 2 in these side to side stripes, and there's 2 with the dots. So I see the fraction 2/3 used how many times? 1 time? I'm going to write the fraction instead of that number 1. I see 2/3 once. I see 2/3 twice. I see 2/3 3 times. And I see 2/3 4 times. So I see 2/3 drawn 4 different ways. And all together they make 2 whole and 2/3. Pretty good. So I see the problem 2/3 times 4 equals 2 2/3. So I'm going to erase my little 2/3 there. So that's one way I see it, right? So that's like the usual problem I would definitely write. But if I'm looking at a multiple choice question and this is not an option, there's no 2/3 times 4 equals 2 2/3. What else might it be? Well, sometimes you just look at the unit fraction multiplication, and in that case you ignore the shading. We're just going to kind of say, well, instead of looking at 2/3, I'm just going to look at different 1/3. So when I do that, I see 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, and 1/3. So if I kind of ignore the shading and just look at all the 1/3s separately, I see a different question. I see 1/3, I see 1/3 times how many times? 1, 2, 3, 4, 5, 6, 7, 8. Now, of course, I still get the same amount, right? That is still 2 2/3. Or again, a lot of times it's kind of obvious to say, when I do 1/3 times 8, sometimes I do the improper fraction and just say it's 8/3. Either one's okay. It doesn't really matter. But when I do that, I just see another way of seeing it. I see 1/3 times 8, or I see 2/3 times 4. And what I hope that helps you see is those are kind of 2 ways of looking at the same thing. Kind of shows me that 2/3 times 4 is equal to 1/3 times 8. Those are the same. They're equal to each other. They both give me this same 2 2/3 amount. So that is 2 different ways to look at the same multiplication model. 2 different problems you can see looking at the same multiplication model. So I hope that made sense to you. If it did not, I would love to encourage you to go back and look at I Do or We Do again and kind of think through these real hard so you're really ready when you get to class tomorrow. But once you feel like you've got it, you're all set. See you then.